In this video, we are trying to understand all the things that is happening in this formula. So there are subscript, there is a negative sign, there is a unit vector and all of this, right? So till now we have been used to f is equal to g m1 m2 by r square. But here you have a subscript, you have a negative sign, you have a unit vector. So what does all of this mean? And is this a convention on how to follow this, right? We need to know all of this. So we are looking at vector representation of gravitational force. So to start off with, we have say 2 point charges m1 and m2 with mass m1 and m2. So what we're looking at is we are looking at the force, the gravitational force exerted by object 1, say on object 2. Right? So basically, let's start off with this. Since we are talking about vectors, we need to start off with the position vectors. So this will be our R1. This is our R2. Since we are looking at force exerted by body 1 on body 2, so we will consider this as the resulting vector. Always. So this we can represent it as 1, 2. So first thing is R12 is a vector from 1 to 2. That's one thing that we have to remember. Again, some books can go with 2, 1 from 2. It depends. But again, this is a convention. So this is something that we have defined. So here, this represents that the force is, the vector is moving from 1 to 2. Okay, guys. So that's what this represents. Next, force by 1 to 2. This is how you represent it. Okay. So this is basically your, whatever this is, entire statement is represented in this way. And this is equal to g m1 m2 by r12 square. So this is magnitude only times of r12 cap. Now, there is a negative sign. Why is there a negative sign? It's actually commonsensical. See, 1 is attracted to, 2 is attracted to 1, right? What is the force, direction of the force? Is it a push force or a pull force? It's a pull force, right? So your F12 is pointing in the opposite direction of R12. And so the negative sign. So F12 is pointing opposite to R12. This indicates it's always attractive force. And so we have this following representation. Okay, guys. So let me show you guys the write-up. So it will make it a bit more clear. So basically you have to follow this. That's the funda. So the convention is that, the core idea is that the convention in central force law, example, gravity, electrostatic, such in all of these places. So you need to know this. It's not only applicable over here, even for electrostatic. So you have the vector R is defined from the source to the point of evaluation. Okay. So basically from and to. So this is the cause and this is what is feeling it. Is the source of the force basically for this example. So it's exerted by object 1. So your vector should start from 1 and end up at 2. So that's the convention. So this convention must be followed consistently. Once the direction of r cap, that is the unit vector, is fixed, signs in the force formula have physical meaning. Then you can talk about it, this being positive or negative, then it will make sense. So since we have fixed R12, since we have fixed this convention, you will end up with a negative sign for all the cases when it comes to gravitational forces, because it's always a pull force, right? How direction works under this convention: the chosen R direction determines the direction of R cap, obviously. The sign in the force law determines whether the forces act along R cap or opposite to R cap. So if it's along the R cap, this means it's repulsion. If it's opposite to R cap, this means attraction. That's what is happening with us over here. So our resulting force is opposite to the unit vector. And so we have a negative sign indicating its attraction. Okay, guys. Again, this is convention. This is basically a rule that we need to understand and use it. A few more things that will make it a lot more clear. Why the minus sign appears? So in our case, R cap points outward, that is from the source mass to the test mass. Gravity is always attractive. This indicates gravity is always attractive, right? Therefore, F vector acts opposite to the direction of R cap. This is why the gravitation vector formula uses a minus sign. It mathematically represents attraction under this fixed convention. So if someone looks at any formula and sees a negative sign, he or she gets to know that we are looking at a case of attraction. For example, in electrostatic, both is possible. When we have like charges, you see repulsion. When we see unlike charges, we see attraction. So in electrostatic, it might make more sense for you guys. As of now, you know that gravity is always going to be attractive. But gravitational force comes under your central forces, right? So it's one of the categories. So all the central forces, they follow this particular convention. And so we just have to follow that convention. As per that convention, you will get negative all the cases. For electrostatic, it can be positive or negative depending on the charges. So you guys know positive and positive charge repel, positive and negative charge attract. Things like this. Okay, so yeah, end of it. Understand what it represents, understand what 1, 2 mean. In this cases, this is always the source and this is the destination. This is the cause and this is the effect. Okay, guys. So this is cause to effect. That's how you can remember. So it should always start from the from and end with to. So put together, you have this formula. Okay, so you can pause and yeah, you can write all of this.